Hey guys, Nate Story here with Bright Agrotech, and today we are going to talk about hydroponic nutrient solutions. 1-part, 2-part, 3-part, multi-part, all these different kinds of solutions. You've got liquid and you've got dry. We're going to talk mostly about dry fertilizers because they're the most economical for commercial growers. So there are 16 plant nutrients, technically, right? We've got carbon, oxygen, hydrogen. These are the things that are supplied by CO2, by oxygen, and by water, right? And they're oftentimes left off the list. You don't have to supply these. Of course, you have to supply water. You have to supply CO2. These things are important, right? But the biggie that we tend to focus on when we're talking about fertilizer are the 13 mineral nutrients. So there's primary, secondary, and then micronutrients. The primary nutrients are the nutrients that basically are used in the highest quantities and the most required for plant growth and development. These are the most common building blocks for the plant. The secondary macronutrients are needed almost as badly as primary ones, and there have been many arguments for including many of the secondary macronutrients as primary nutrients. However, for the time being, they are classified as secondary macronutrients, and they're still very, very, very important, but not quite as important as the primary plant nutrients. The micronutrients are all of the mineral nutrients required in much, much smaller quantities by the plants for growth and reproduction. Okay, and all of these nutrients, both the primary, the secondary macronutrients, and the micronutrients, are all supplied by hydroponic nutrient solutions if you're doing hydroponic production. So the primary nutrients are nitrogen, phosphorus, and potassium, right? NPK. And these are on the label of every major fertilizer because they're the most important. It's really important that you understand how much of each one is in a particular fertilizer. So nitrogen, incredibly important for plant growth and reproduction. It is incorporated into all sorts of molecules that are involved in photosynthesis. So chloroplast, photosynthesis, nitrogen is very important. It's very important in proteins, right? These are not just photosynthesis specific proteins, but proteins that operate all through the cell. Phosphorus, important part of the cell membrane, important part of all of these different biological molecules. And then, of course, potassium, plant signaling, root growth and development, reproductive growth and development. These are all really, really critical nutrients to plant production and to growers who are interested in maximizing their plant production. Secondary macronutrients, calcium, magnesium, and sulfur, are very important in, calcium is super important in bonding cell walls. It's a structural element. Calcium's a really weird one. And actually, there's been a lot of people that have argued that calcium should be a primary plant nutrient, and it typically is supplied in very large quantities in hydroponic solutions as a result. Magnesium, an important part of the photosynthetic kind of complex. Sulfur, incredibly important in peptide bonds and DNA and all of these different molecular biological compounds and biological molecules that the plant needs to grow and to reproduce. Essentially, the reason that the primary and the secondary macronutrients are so important is because they're the most common nutrients. They're used throughout the plant for a variety of different activities. The micronutrients are still absolutely critical. Without any one of them, the plant will die or can only survive for a certain number of generations for things that are only supplied in very small quantities. Some of them are required in such small quantities that the parent plant producing a seed, in that seed is enough of that micronutrient for the entire life of that daughter plant. However, the seed that plant produces, if it doesn't have enough, the generation after that will fail. So some of these are required in very small quantities, but they're still required. And that is kind of the key thing with the micronutrients. Just because they're required at fairly low levels does not mean they're critical. So the way that we measure hydroponic fertilizers is with a measurement called EC. It's short for electrical conductivity. And basically what we're doing is we're sticking a probe in the water and we're passing a current between these two probes, and the way that current is transmitted is basically the strength of that current tells us how many soluble salts are in that water, right? So how many ions we have floating around in here, and how easy is that electrical current passed from one probe to another. So EC is measured a variety of different ways. If you're measuring electrical conductivity property, it's mostly milliohms or microsiemens per centimeter. Those are the two primary measurements. ppm is sometimes used, but that's more for total dissolved solids, which is a slightly different measurement. We typically shoot with most hydroponic solutions for something, we're usually using millisiemens per centimeter, and we're usually shooting for somewhere between 1.2 for plants that really don't like a whole lot of salt or uptake a ton of water, all the way up into the low 3s for some crops that are more salt tolerant that we want to pump full of nutrients. So there's a broad range there that is specifically crop appropriate. And if you have questions about what your EC value should be for each individual crop, check out the crop production guide that we publish. It's got all of that information there. So EC is a really, really simplified measurement of a very complicated thing. Now, the great thing is with modern chemistry, all of our solutions are formulated. That means we know exactly how much of each element is in each thing. And we can formulate these nutrient solutions specifically for individual crops. What that means is if we put it all in at the right ratio and the plants are taking everything out at the exact same ratios, then by measuring the electrical conductivity, we can tell the salt content of the water or how much nutrition is actually there. And if it's all being taken out at the exact same rates, we don't usually end up too far off balance. What this means is with a formulated solution and with this simple EC measurement, we can measure when we need to add more nutrients to the water and when we have too much nutrients in the water. So EC measures the amount of these soluble salts that are in the water, right? The amount of fertilizer that we have in the water. Now, the availability of that is still somewhat variable depending on a measurement called pH. pH measures the acidity of the water, so how acid or how basic the nutrient solution is. And what the interesting thing about it is it doesn't matter if you've got the right amount of plant nutrients in the water if our EC is so far off, because different nutrients are soluble at different pH values. So pH influences the solubility of each individual nutrient. So there are lots of graphs online. If you just Google, nutrient solubility chart, something like that, you're going to get a host of images that show these bands across multiple pH values that tells you where the ideal, the most soluble pH value is for each individual mineral on that list. Now, it's important that we're managing both EC and both pH, because EC puts the nutrients in the water and pH makes the nutrients available to the plants. And that's the critical thing. Those are the two most important things when it comes to managing your nutrient solution and making all of those plant nutrients available for your plants. So optimal pH is typically somewhere between the low 5s and the low 6s for most crops. Some crops will prefer it a little bit higher. Some crops will prefer it closer to 7. Some crops will prefer it in the high